Everyone, welcome to A's Data Science. Today we are going to do the graded assignment of Week 5 for Maths-2. So, without wasting any further time, let us just directly jump on the questions. Question number 1 basically says that the marks obtained by Kartika, Romi and Farzana in Quiz 1, Quiz 2 and N terms are given in the below table. And if x1% of Quiz 1, x2% of Quiz 2, x3% of N terms are taken under consideration for total marks, then select which of the following options are correct. Okay, so first of all, the general form for TR is going to be Q1 into x1 plus Q2 into x2 plus Q3 into x3 and whole divided by 100. The reason behind dividing it by 100 is just because the portion that we have to take from each exam for the final marks is given in the percentage. Now if we look at the first two options, the first two options are asking about the correct general form of T2. T2 is the final marks of Romi and her respective marks in each exams were 20, 50 and 50. So, the correct general form will be something look like 20 into x1 plus 50 into x2 plus 50 into x3 and whole divided by 100. So the correct option that resemble the general form of Romi's total marks is option number 1. Hence, option number 1 is correct. Now if we look in third, fourth and fifth option, the third, fourth and the fifth options lies on a same case where we have fixed the input of each xi. And we have to check the marks for Kartika and whether Farzana got the highest marks among the three or not. Given x1 is 20%, x2 is 20% and x3 is 60%. Now, let us first calculate the marks of T1. So, T1 is going to be equal to 40 into 0.2 plus 50 into 0.2 plus 60 into 0.6, which is equal to 54. Hence, the option number 4 is correct. Now, let us calculate the marks of T2. So, T2 is going to be equal to 20 into 0.2 plus 50 into 0.2 plus 50 into 0.2. Which is basically equal to 24. Now, let us calculate the marks of T3. So, T3 is going to be equal to 30 into 0.2 plus 40 into 0.2 plus 70 into 0.6, which is basically equal to 56. The highest marks among these three is 56, which is for T3 means Farzana got the highest marks. Hence, option number 5 is also correct. Now, the last option asks that whether it is a linear transformation from R3 to R or not. We know that if a transformation can written as a matrix multiplication, then it is a linear transformation. And here we can clearly see that it can be written as a matrix multiplication. Hence, it is a linear transformation. It means that option number 6 is also correct. So the correct options for question number 1 is option 1, option 4, option 5 and option 6. Now let us move to the second question. Question number 2 basically says that a molecule of carbon dioxide consists of one carbon atom, and to oxygen atom a molecule of water is consist of 2 hydrogen atom, and 1 oxygen atom, and a molecule of glucose is consist of 6 carbon atom, 12 hydrogen atom and 6 oxygen atom. And a chemical reaction is also given below, which is basically carbon dioxide combined with water in the presence of sunlight to form glucose and oxygen. And one more point that is given is to balance a chemical reaction there should be same number of atom of any molecules on both sides. Now from the given options we have to select which of the following options are correct. Firstly, we know that to balance a chemical reaction there should be same number of atom of element on both sides. It means that here in this question, we should have the same number of hydrogen on both sides, we should have the same number of oxygen on the both side and so on the same number of carbon on both sides. Now let us obtain some equations by balancing the equation. Let us first balance carbon atom. In left hand side the carbon atom comes from CO2 having 1 carbon atom. And on right hand side it comes from the glucose having 6 carbon atom. So, from this balancing we got an equation of x1 is equal to 6 times 3. And similarly, the equation obtained from balancing the hydrogen is again x2 is equal to 6 times 3. Again after balancing the carbon, the equation that we got is x4 is equal to 6 times 3. So, what we get is x1 is equal to x2 is equal to x3 is equal to 6 times 3. Now the first two options in the second question ask about the nullity. We know that nullity is the number of independent variable, and here it is clearly seen that the number of independent variable here is only one, which is x3. Hence, nullity is equal to 1. So, option 1 is correct. Now the third and the fourth option ask about the basis of the null space. We know that to create the basis of null space, we have to module all the dependent variable into the terms of independent variable. So suppose x3 as t, then x1 is going to be 6 times t, x2 is going to be 6 times t, x3 is t, and x4 is again going to be 6 times t, or it is basically 6, 6, 1, 6. Hence, the option number 3 is also correct. The fifth and the sixth option is going to be wrong because the nullity is only 1. S0, the null space, can contain only one vector. But in both options, the basis of the null space containing two vectors. Hence, both the options are wrong. Now the seventh option says that whether it have many solutions or not. So yes, it is going to have many solutions because t can be any real number. Hence, the last option is also correct. So the correct options for portion number 2 is going to be 1, 3 and 7. Now let us move towards the question number 3. Question number 3 says that choose the set of correct options from the given options. The first option says that null space of a scalar matrix is always going to be a zero vector space. We know that a vector is a part of null space if and only if A into x is equal to 0. And this statement is actually true when it is non-zero scalar matrix, because in such case the only possibility for which the vector will be in the null space is that when it is a zero vector, but when A is a zero scalar matrix, then any vector will always going to be result in zero vector. Hence here every vector is a part of its null space. Hence first option is wrong. Now the second option says that null space of a non-zero scalar matrix is always going to be a zero vector space. Now this point we already explained in the previous question that if it is a non-zero scalar matrix, then only the zero vector is going to be in the null space, hence its null space is going to be zero vector space. So the option number 2 is correct. Now the third option says that the nullity of a non-zero scalar matrix is always 0. Now, this option is also correct because a non-zero scalar matrix is of full rank, or we can also say that it is independent, so its nullity is always going to be 0. The fourth option says that the rank of a non-zero matrix is always same as its order of matrix. I just told a point in previous option that non-zero scalar matrix is of full rank or it is independent. Hence, its rank is going to be equal to its order. Hence, option number 4 is also correct. Let us now see option number 5. Option number 5 says that the rank of a non-zero scalar matrix is 0. This option is a contradictory statement of the previous option, and we just find that the previous option is correct. Hence this option, or the option number 5. Now let us move to the question number 4. Question number 4 says that A is a 5 cross 3 real non-zero matrix. Choose the set of correct options. Okay, before jumping to options, let us first see the general form of A, which is something look like this. Now, the first option says that the nullity of A can be at most 2, since there are 5 equations and 3 variables. So the maximum rank is going to be 3, as rank is the number of pivot column or non-zero rows, so the number of possible pivot column in this case is going to be 3 only, hence the maximum rank is going to be 3. And since it is given that it is a non-zero matrix, so the minimum rank is going to be 1. Hence the maximum nullity is going to be 3 minus 1, which is going to be 2. So the correct options for this question are the nullity of A can be at most 2, which is option 1, and the rank can be at most 3, which is option 3. Now, let us move towards our next question, which is question number 5. Here, we have to basically check which of the following maps are linear transformation. We know that a transformation or map is said to be linear transformation if and only if it holds the two property. The first one is additive closure and the second one is scalar multiplication. Now let us see the first map. T is from R2 to R such that T of x comma y is 8 times x minus 10 times y. Now let us first check for its additive closure. So if we check whether T of V1 plus V2 is equal to T of V1 plus T of V2, then we will find that additive property holds here. Now, let us see the scalar property, or let us check whether transformation of C times V is equal to C times transformation of V. This map clear the scalar property also. Hence, the first option is a linear transformation. Now let us see the second map. T is a map from R to R2, such that transformation of x is equal to 4 times modulus of x, 0. Okay, so before solving this option, there is a point that you all have to keep in mind is, if the transformation contain any extra constant means the addition of any extra constant or subtraction of any extra constant, any trigonometric value, any absolute value, any power or any log, then the map is not going to be a linear transformation. Now if we look in the transformation of option number 2, there is the absolute value in it which is multiply by 4, hence option number 2 is not going to be a linear transformation. Now let us see the third map. T is a map from R2 to R2, such that transformation of x, y is equal to 10 times x plus 8 times y, 3 times x minus 4 times y. Now here if we check whether it holds the two required property for a linear transformation or not, then we can clearly get the point that this third map is going to be a linear transformation, as it holds the both additive property as well as scalar multiplication property. Hence option number 3 is true. Now let us move toward the fourth option. It is a map from R2 to R3, such that transformation of x, y is equal to 3 times x plus 1, 8 times x, 8 times x plus 4 times y plus 6. I just mentioned a point that if a map contain addition of an extra constant, then the map is not going to be a linear transformation. And here in this map it is clearly seen that in the first term and the last term there is an addition of constant. Hence the last option is not going to be a linear transformation. Let us now move towards the question number 6. Question number 6 says that, consider a map from R2 to R2, such that transformation of vector V is equal to A into V, where the matrix is already given. And we have to select which of the following options are correct. We know that if a map can be written as matrix multiplication, then it is a linear transformation. And here it is clearly seen that it can be written as in the form of matrix multiplication. Hence it is a linear transformation. Which means that option number 3, which basically says that T is a linear transformation, is correct. Now, there is a point that if the coefficient matrix of linear transformation is a square matrix having non-zero determinant, then the linear transformation is going to be isomorphism. Since we are already provided with the coefficient matrix for this linear transformation, let us find its determinant. Its determinant is going to be 30 minus 13, which is non-zero. Hence this linear transformation is going to be isomorphism. And we know that if a linear transformation is isomorphism, then it means that it is 1, 1 and onto both. Hence the option number 4 is also correct. So the correct options for the question number 6 is option number 3, which basically says that T is a linear transformation. And option number 4, which basically says that T is the both 1, 1 and onto. Now, let us see the question number 7. Question number 7 basically says that, consider a 4 cross 4 matrix that is given below. From the given options, select the options which are correctly representing the basis of null space of this matrix. We know that to form a basis of any space, first we need to make our EF of the matrix. So, if we make the REF of this matrix, it would be something look like this one. Now we know that the null space is expanded by independent variable. And here there is only one independent variable, which is variable 4. Hence, the correct basis is going to be 0, 0, 0, 1, which match to option number 4. Hence, the correct option for question number 7 is option number 4. Now let us move towards the question number 8. Question number 8 says that, let A be a 4 cross 3 matrix and B be a 3 cross 4 matrix. If the null spaces of A and B are three-dimensional vector spaces, what is the maximum possible rank of A into B? So, we know that the rank plus nullity is equal to number of columns in a matrix. And we are already provided with the nullity of both matrices, which is 3. So if we calculate the rank of matrix A, which have only 3 columns, then its rank is going to be 3 minus 3, which is equal to 0. And similarly, the rank of B is going to be 1. Now we know that the maximum possible rank of A into B is going to be less than or equal to minimum of rank of A or rank of B. And here the minimum rank between A and B is of matrix of which is Hence, the maximum possible rank. Now let us move to question number 9. Question number 9 basically says that Shubham, Paul, me, Asrif, Rafeel and Vicky sum a same pen drive from a particular shop. And they have to rate the quality of pen drive on the scale of 0 to 5. And each rating will represent a vector, like suppose someone give 3 star, then its vector will something like 00100. There is an example of rating is also given in the below table. From the given options, we have to select the correct options. The first option says that if Shubham and Paulmi both gave 2 stars rating, Asrifa and Rafal both gave 1 star rating, and Vicky gave 3 stars rating, then the dimension of the vector space spanned by the row vectors corresponding to the ratings is 3. So if we first make a matrix where each row represent the rating given by each person, then the matrix will be something look like this. Later if we reduce it, then the matrix will be something look like this. Now we know that the dimension or rank of a matrix is basically the number of pivot column or the number of non-zero rows. And here it is clearly seen that there are only 3 non-zero rows. Hence its dimension is 3. So the option number 1 is correct. Let us now see the option number 2. If Shubham and Vicky both gave 3 stars rating, Paulmi gave 2 stars rating, Asrifa gave 5 stars rating, and Rafal gave 1 star rating, then the dimension of the vector space spanned by the row vectors corresponding to the ratings is 4. Now again, if we make the matrix representing the rating and later if we make its reduced row form echelon form, then we will clearly see that there are 4 non-zero rows. Hence its dimension is going to be 4. Means that option number 2 is also correct. Now if we see the option number 3, which says that if Shubham gave 5 stars rating, Paulmi gave 3 stars rating, Asrifa gave 1 star rating, Rafal gave 2 stars rating, and Vicky gave 4 stars rating, then the dimension of the vector space spanned by the row vectors corresponding to the ratings is 5. Again, after making its matrix and after reducing it, we clearly see that there are 5 non-zero rows. Hence its dimension is going to be 5. Hence the option number 3 is also correct. Now let us see the option number 4. If Shubham, Paulmi and Asrifa all gave 2 stars rating, and Rafal and Vicky gave 1 star rating, then the dimension of the vector space spanned by the row vectors corresponding to the ratings is 1. If we make the matrix and reduce it, then we will clearly see that there are 2 non-zero rows. It means that the dimension of this particular case for the option number 4 is going to be 2, but here the given dimension is 1, so it means that option number 4 is wrong. Now let us move to the question number 10. Question number 10 basically says that A is a 5 cross 5 matrix that is given below. And from the given options, we have to select the correct options regarding the matrix A. First of all, let us make the reduced row echelon form of this matrix. So it would be something look like this one. Now the first 2 options ask about the basis of null space. We know that the basis of a null space is spanned by independent variables, and here there are only 2 independent variables as x3 and x4. So the basis will be something look like it will contain 2 vector, and the first vector will be 00100 and the second vector will be 00010. Hence the option number 2 is correct. Now the last 2 options ask about the nullity of the given matrix. We know that the nullity is basically the number of vector in a null space, or basically the number of independent variable after the reduced row echelon form. Hence its nullity is going to be 2. It means that option number 3 is also correct. So the correct options for question number 10 is option number 2 and option number 3. Now let us see the question number 11. Question number 11 basically says that what is the rank of a matrix that we defined in the previous question. Since the nullity of this matrix is 2 that we just now find, and its number of columns is 5 as it is a square matrix of order 5. We know that number of columns is equal to rank plus nullity. So rank here will be equal to number of columns minus nullity, which is going to be 5 minus 2, which is equal to 3. Hence, the rank of matrix A is 3. Now let us move towards the question number 12. Question number 12 basically says that M is a M cross N matrix and A is the RREF of M. From the given options, select the correct options which are equivalent to the nullity of M. Let's see the option number 1. It says that nullity is equal to m, which is number of rows minus rank. But the actual term is different and something like nullity is equal to number of column, which is here, n minus rank. Hence the option number 1 is false. Option number 2 says that nullity is equal to n minus rank. So, just in previous question I said that correct form will be number of columns minus rank, which came from the fact that number of columns is equal to nullity plus rank. Hence the option number 2 is correct. Let us now see the option number 3. It says that nullity is equal to number of non-zero rows in M. So first of all, M is not a reduced echelon form, means that its zero or non-zero row will not define anything. Secondly, number of non-zero rows in reduced echelon form is basically the rank, not the nullity. Hence option number 3 is also wrong. Let us now see the option number 4, which says that nullity is equal to number of pivot elements in A. This option is also wrong, as the nullity is number of independent variable or non-pivot element in reduced echelon form. Let us now see the option number 5. It basically says that nullity is equal to number of independent variable for the system mx is equal to 0. Hence this option is true. And the last option, which is option number 6, says that nullity is equal to number of independent variable for the system ax, so this option is also true. So, the correct options are option number 2, 5 and 6. Let us now see the last question, which is question number 13. Question number 13 basically says that t is a function from R2 to R2, such that t of 1, 0 is k, 1, t of 0, 1 is equal to 1, k, t of 2, 1 is equal to minus k square plus k plus 1, 2 minus k square. It is given that k is a real number and it is a linear transformation where it is not a 1-1 function. Since it is given that this linear transformation is not a 1-1 function, so the coefficient matrix determinant should be equal to 0. So by equating its determinant to 0, we can find the value of k. The value of k that we will obtain is plus minus 1. Now let us determine whether k is equal to 1 or k is equal to minus 1. Okay, we are provided with matrix A. And we know that transformation is basically A into V. So if we make the transformation of 2, 1, it would be something like matrix A multiply by 2, 1, which results something like this. Now in the question we are already provided with a general form of transformation of 2, 1. So if we equate the first terms from the both equation and try to solve for the value of k, then the value of k that we are going to obtain is 0 and minus 1. And the only value which comes in both condition is minus 1. Hence, the value of k is going to be minus 1. Okay, that is it for the week 5 graded assignment of Maths 2. If you really learned something from this or any